Hey guys, here we are. This is going to be our lesson 6.5 now. Last time we talked about section 4.6 where we learned a little bit about arithmetic sequences. This time we're going to learn what geometric sequences are about. Take a look, and this is also in your packets, at this sequence of numbers 1, 5, 25, and 125. This time, what is going on? The next term is being generated as you multiply by 5. Take a look at this. This is now what we call a common ratio, and we're going to use letter R to label it. Last time when we were doing section 4.6 in arithmetic sequences, we had something similar, remember? We had the common difference, and we used letter D to label it. Well, hopefully you will see some similarities, and I'm going to do another example, not using this 1, 5, 25, and so on, but a different one. Hopefully this will give us some better ideas of what is going on. Let me begin with the first term. Remember that the first term, we already have a way to label it with a 1. I'm going to use this time this generator of new terms, which is the common ratio, which is R, and we are going to multiply by 3 to generate new terms, which means that the next term here should be a 6. And remember, this is what we call A2, which means that if you want to know A3, well, it should not be that hard now. We are just going to multiply this 6 by 3, and then you get this 18. And let's do it again. We multiply by 3 again, and after that 18, you get a 54, which is your fourth term of the sequence. And now you are realizing something. If we start with the first term, just like it happened with arithmetic sequences, and then we multiply several times, we are going to eventually find the term of the sequence we're trying to find. So, how are we going to find the fifth term starting from the first one? Well, easy. If you take a look at this, and let me show you this. A5, what is going to happen is that we're going to take the first term, and how many times am I going to do this? Well, look at this. We're going to do it 1, 2, 3, and then finally 4 times. So it should be something like this. A1 multiplied by that common ratio 1, 2, 3, and 4 times. So this is really important because it is really similar in the way that we did with arithmetic sequences. If I want to find the fifth term, I am going to take the first term and multiply it by the common ratio 4 times. It means n minus 1 times. But remember that we can rewrite this multiple multiplication right here. This one right here, the one that I am writing inside this square, this rectangle, sorry. So A1 multiplied by R to the power of 4, okay? That leads us to another possibility. And by the way, you multiply by 3 and you get this 162, right? So it means that if I wanted to find the 22nd term, it means that I'm going to take the first term of the sequence and multiply by that common ratio raised to the power of 21, okay? In this specific case, in our geometric sequence, which by the way, we call them geometric sequences because they have a common ratio, just as you read in the definition. And remember, we need to use the definitions. Now, we can give a general way of saying this. Oh, but before, sorry, I was doing the 2, 6, 18, 54. So if I wanted to find any given term for this sequence, the one we have here, we are going to take the first term, which is 2, okay? First term is 2, and how about R? R is 3. So we are going to take 2 and multiply it by 3 n minus 1 times. This is what we call the nth term rule, or we can also label it as the explicit rule or explicit formula for this sequence 2, 6, 18, 54. One thing that I want you to notice is that this R, this common ratio, is it's possible that it is negative, all right? It can be negative. You might also see that geometric sequences are really similar to exponential functions, just as arithmetic sequences are similar to linear functions. The only difference between geometric sequences and exponential functions is that in geometric sequences, R can be negative. Keep this in mind, and let's take a look at some exercises, okay? Pause as needed, please. If you need to pause and then rewind a little bit, do so, please. I want you to really understand this. It's not that hard. I don't have to be in front of you to help you understand this, as hopefully you have noticed already. Look at this. Is this going to be arithmetic, geometric, or neither? Let's take a look. If you go from 1 to -4, from -4 to 16, from -16 to -16 to -64, it means that we are multiplying by the number -4. Okay? In this case, what is going on? Is this a geometric? It's a question, right? Is it geometric? Are we do we see a common ratio? As you might notice, this is +4, so it means that this is arithmetic. It's not geometric, okay? And so on. So hopefully you understand now that we need to have this repetitive multiplier or factor, or what we call it, the common ratio. But now, guys, I want us to take a look at these exercises down here, where we want to write an equation for the nth term of the geometric sequence, okay? So I'm going to do a couple of exercises, and hopefully, again, pause it as needed, rewind as needed, and make sure that you understand how we get this. Once you find that equation, then we have to find the sixth term of the sequence. So I'm going to do number 14, number 15, number 16. So let's begin. Let's begin by identifying A1. Here, A1 is number 8, right here. How about R? Well, let's take a look. If you go from this to this, and from this to this, 8 times 3 is 24, but not -24. So it means that R is -3. And it fits, okay? Can you see that we are alternating positive, negative, positive, negative? It means that we are doing a negative number. I already have what I need. So the nth term for this geometric sequence, nth term rule, or explicit formula, okay? It's going to be A sub n equals the first term, which is 8, multiplied by -3 raised to the power of n minus 1. Now they want us to find, and I'm going to do it on the left, they want us to find the sixth term of the sequence. Well, it's simple. We begin by taking 8 and we multiply it by -3 how many times? If there's a 6 right here, there's going to be a 5 right here. So A sub 6, or A6, it's going to be 8 multiplied by -3 raised to the power of 5, okay? And that is going to be a -243. And then you finish by multiplying 8 times -243, which is -1944, and we're done. Okay? Again, pause as needed, rewind if you want to take a look at the exercise again. Exercise 15, as you can see, okay, what is A1? It's 3. What is R? Let's see. from 3 to 15, from 15 to 75. It seems like we are multiplying by 5, okay? So R is 5. So the nth term rule, or the explicit formula, goes like this. A sub n equals A sub 1, which is 3, multiplied by 5 raised to the power of n minus 1. For this exercise, A sub 6, or A6, is 3 times 5 raised to the power of 6 minus 1, which is 5. Okay? So once you do that, remember, you do the power first. Don't do 3 times 5 equals 15. Please don't do it. So this is going to be 3 times, and we solve this power first, which, by the way, is 3,125, right? And then you just do this multiplication by 3, okay? So then you will have A6 equals 9,375, okay? Here's your answer. Finally, let's do number 16. Now, this is getting a little bit harder because we need to make sure that we find a common factor, common ratio here, common multiplier. But it seems like this definitely will be a number less than 1. Because as you see, the sequence is going down, is decreasing. So how do I find it? Well, before we start, we have A1 is 2,916. But how do I figure out R? Well, just like we did in exponential functions trying to figure out B, I'm going to take any of the A sub n numbers. So let's say that we get 324. And you are going to divide it by the previous term, 972 this time. When you do that, you will get 0.33333, right? And so on. This is, and this can also be better expressed as the fraction 1/3. No matter how you do this, like for example, 108 divided by 324, when you simplify this fraction, you get 1/3. So conclusion, R is 1/3. So the nth term rule for this specific sequence would be A(n) equals A1 is 2,916, and this is going to be multiplied by 1/3 raised to the power of n minus 1. Now, we want to find A6. Okay, we're taking the first term, 2,916 times 1/3 raised to the power of, remember, 5n minus 1. So this is going to be 2,916. 1 to the power of 5, 3 to the power of 5. Okay? 1 to the power of 5 is 1. 3 to the power of 5 is 243. Okay? Once you do this, it's the same thing as if you had 2,916 divided by 243. Okay? Once you get to that point, then this is going to turn into a 12. And that will be all. This is all about geometric sequences. Let me review the summary for you. A geometric sequence is a set of numbers, right? That as you generate the new one, you do it using a common ratio, okay? And the first term is relevant here if we want to know what the explicit rule is, or the equation for a geometric sequence, as you can see it here. A sub n, begin with the first term, and then you multiply it by R, the common ratio, raised to the power of n minus 1. Can you see these two, how they are related? We already saw it when we were doing arithmetic sequences. Guys, this is all. Hopefully you are now able to work on your homework assignment on 6.5 and also work on the other exercises for this packet. Remember that the packets are important for your retakes. Okay, thank you so much. This is all for now.